Hello everyone, my name is Ritik Yadav and welcome to this session. If I were to ask you what is the common link between the trajectory of a missile and the cooling of a hot cup of coffee and the fluctuations in the stock market, the answer will be one single mathematical tool called the linear differential equation. Today we are going to master the heart of this topic, that is linear differential equation or simply LDE. So many students memorize the formula for this kind of topic, but today we will not do that. We will see why integrating factor works and how can we intuitively see how do we calculate integrating factor and why do we calculate integrating factors. So first of all, we have to know what is the standard linear form of linear differential equation. This is the standard linear form of linear differential equation. Why is it linear? Because we can see dy by dx is free of any. First we know that linear differential equation is a equation which has no functions of y or dy by dx multiplied with each other. This is a linear differential equation and we will see how can we solve this. So first, what can we do? In many books we see that they simply say that multiply both sides by e to the power p dx. But why do we multiply with this? This is not magic. We are not magician. We are what? We are mathematician. So there has to be some logic behind it. Why do we multiply by this? So let's see why do we multiply this. Suppose we multiply in our equation, multiply by ix. What do we get? We will get dy by dx ix plus ix px times y and ix qx. Now what do we want from this? We want actually d by dx of y dot ix. In our LHS we want this to be this. That is our goal. If we open this, we will get ix dy by dx plus y I derivative of x. Now if we compare this with our first equation, we can see that this term is the same, and here if we compare, y is here and I dash derivative is this one, so it has to be equal to this because we want our LHS to be this, and by expanding this we get this, so it has to be like I derivative x has to be equal to ix and px. Now which implies we can write I dash x divided by ix is px. Now if we integrate both sides, integrate I dash x by ix dx, of course with respect to x, is equal to integrate px dx. What do we get from here? Say we can take ix to be t. If we take ix to be t, its derivative and dx will be dt. So by simple substitution we get dt by t, and what is the integration of dt by t? Log t, and again we can replace the t with ix. So simply we can say ln mod ix is equal to integration px dx. So remember, this is always mod x, not ix, because ln has to be like domain has to be every positive value in the domain of ln. But we have we can say that ix is something positive function. Ix is a function of x that is positive. So this mod can be removed. So this implies ix is equal to e to the power integration px dx. This is called the integrating factor. We have assumed since ix is positive, so its modulus will be positive value. Now, what do we benefit from this? We can remove this part. What do we get? If we multiply this equation by e to the power this, then it will be LHS d by dx of y times e to the power integration px dx is equal to ix. What was ix? E to the power integration px and dx and qx. Now, if we integrate it both sides with respect to x, we will get on integrating both sides with respect to x, we will get y dot this is called say integrating factor. This will be y dot integrating factor is equal to integration qx integrating factor dx plus c. This will be our final answer. This is how we solve simple standard linear form with respect to linear differential equation. Now we will solve one simple example by applying this simple theorem. We see here that this is, first of all, is it standard linear form. We see that if you open this, it will be like x times dy by dx, that is fine, x times dy by dx and 2y cube dy by dx is equal to y. But if we multiply x, then it is fine, it is standard linear form, but we don't want this. Y multiplied dy by dx is not linear, so we can't do this, right? So what can we do? First of all, we will put all these LHS into here, x plus 2y cube. Why did we do that? Because y multiplied dy by dx is not linear. Okay. Now what can we do? If we take dx by dy, we are trying to make it linear, right? So we will write like this, divide by y. This will be x by y plus 2y square. Now take x by y to the left hand side, dx by dy minus x by y is equal to 2y square. Now, is it linear? Of course, because we have dx by dy, x by y, and this is linear in terms of this is linear in terms of x. Here our dependent variable is x and independent variable is y, right? So now we can apply integrating factor method. What will be your integrating factor? e to the power, what is px? Px is minus 1 by y, 1 by y dy, and integration of minus 1 by y is minus time ln y, which is y to the power minus 1, that is 1 by y. We have to now simply just put x into integrating factor is equal to integration qx. What is our qx? 2y square into integrating factor dy plus c, that is x into 1 by y is equal to integrating factor 1 by y dy plus c. This will be cancelled out. We get y square plus c. So our final answer will be x is equal to y cube plus cy. This is how we can solve very easily by applying integrating factor. Now we will move to our second question. Second problem, that is 1 minus x square dy by dx plus 2xy is equal to x times 1 minus x square. Is it linear? We can see dy by dx is multiplied by 1 minus x square. There is no function of y, so yeah, this is linear. So first of all, what we'll do, we will shift this 1 minus x square plus 2xy divided by 1 minus x square is equal to x under root 1 minus x square divided by 1 minus x square, right? This is a root, this is a power 1, so it will be x over under root 1 minus x square, right? So what is our px? Px is 2x upon 1 minus x square, and this is qx. We will simply find first integrating factor e to the power integration 2x upon 1 minus x square dx. Now what is the integration of this? By simple substitution, say 1 minus x square is equal to t. This will be minus 2x dx is equal to dt, right? So what we will get? E to the power integration 2x dx is minus dt, and this is simply t. This will be e to the power again minus ln t, that will be 1 by t, and t is our 1 by x square, right? Okay. Now put this in our first equation here. This is equation 1. We will get y dot integrating factor 1 minus x square is equal to integration x by 1 minus x square multiply 1 by 1 minus x square times dx plus c. Now if we substitute 1 minus x square to be, again substitute 1 minus x square is equal to say m, then it will be, or say u, we will get x dx is equal to x, you can say, you can take to u square because we want square root to be removed. Okay, this will be minus u du. Why? Because 2 from here and 2 from here will be cancelled out, and this minus will be here. So replacing this in equation, we will get y by 1 minus x square is equal to integration x dx. X dx is minus u du divided by 1 minus x square is u square under root, so u, this will be u, and this is our u square, plus c, u is cancelled out. We will get integration of du upon my u square will be minus 1 by u, but there is already a minus here, so it will be plus 1 by u plus c, and u is what? U is our under root, we can write here, u is 1 by under root 1 minus x square plus c. So final answer will be yx is equal to under root 1 minus x square plus c bracket 1 minus x square. This will be our final solution. So very easy topic, and we, like every year, we get a lot of questions from this topic. If you know the basic concept of integrating factor, you can simply apply it. Thank you.